Okay, in this question we're given an equilibrium reaction with bromine and chlorine gases in equilibrium with two molar equivalents of bromine chloride. It also provides us the Kp value. That is the equilibrium constant with respect to pressure. Once this system is at equilibrium, it says that it's equal to 7. At this point it tells us that this reaction is set up, and initially, right at the setup, it gives us the pressures of each of these individual gases. It says that at setup it's filled, or there's a chamber filled with 1 atmosphere of bromine, 1 atmosphere of chlorine, and 2 atmospheres of bromine chloride. It then asks us to use Q to determine which of a list of statements is true. First of all then, we have to determine what Q is. Q is of course the same thing, or the expression for Q is exactly the same as that for K. So in this case, Q is going to be equal to, and with respect to pressure I should say, Qp is going to be equal to the pressure of the product, bromine chloride, squared, because it has a 2 coefficient, that becomes an exponent here, divided by the individual pressures of the reactants, Br2. There's a coefficient of 1 in front of that, so that becomes an exponent, multiplied by the pressure of Cl2, whose coefficient is once again 1, which becomes an exponent. So let's go ahead and put these numbers in here. I have 2 as the pressure at initiation for the bromine chloride, so I'll go ahead and put 2 in there on the top and square it. And my initial pressures for bromine and chlorine respectively are 1 and 1. If I throw that into my calculator, or my brain I guess, that is going to equal 4. So this is Q, the reaction coefficient at this particular moment in time. It is not obviously equal to K. So what has to happen to this reaction in order for it to become equal to K? In which direction is it going to have to drift? Well, as we look at this mathematically, you can see that the problem with it, you can see that Q is smaller than K. In order to have Q become equal to K, we're going to have the numerator, which is this bromine chloride pressure, go up. That means that right now, at initiation, this reaction is imbalanced because there's not enough of product. So this reaction is going to have to drift to the right to create more product, increase the pressure of this, increasing the numerator, and eventually getting the final mathematical calculation to come out to be 7. I hope that that makes sense. So with that said, let's look at the multiple choice options. Option A says, the equilibrium partial pressures of bromine, chlorine, and bromine chloride will be the same as the initial values. Going back here to what we've written on the board, here are the initial values. Does it make sense that these initial values are going to be the same as what they would have at equilibrium? Well, of course that doesn't make sense at all, because the initial values are such that Q ends up being 4, and it needs to be 7, so that first statement is complete rubbish. Let's look at statement 2. The equilibrium partial pressure of Br2 will be greater than 1. Going back to what we've noticed here, what we need is for this number to go up to become 7. The only way you can do that is by increasing the numerator and decreasing the denominator. The denominator pressure of Br2 is already at 1, so you're going to have to make it go lower. So that statement also is false. Let's look at option C. At equilibrium, the total pressure in the vessel will be less than the initial total pressure. At the outset, that is somewhat unclear. We can imagine once again that we need to increase the pressure of the numerator while decreasing the pressures of the denominator components. What will the total pressure of all of those together in the system be? Well, I think they're probably going to have to end up being larger than they were at the outset, because at the outset they just give you a Q of 4. Let's move on to option E. Option E says the reaction will go to completion since there are equal amounts of Br2 and Cl2. That option is complete nonsense, because this is an equilibrium reaction. There's no such thing as it going to completion. A completion reaction would be one in which we have a one-way arrow, so we're talking about reactants converting completely to products, which is not the case here. Option D then says the equilibrium partial pressure of bromine chloride will be greater than 2 atmospheres. Going back to our initial reaction quotient here, this numerator needs to get bigger. Right now it's at 2, and at 2, the reaction quotient is 4. As I've already stated, that needs to go up in order to reach equilibrium K value of 7, so that numerator will be larger than 2. So the equilibrium pressure of bromine chloride will be greater than 2, and therefore, the correct answer to this question is D.